plug in a USB-C cable and USB-A goes to your PC. What's up guys, welcome to Intriguing Tech. Today's video is about using a Raspberry Pi Pico device to help solve incompatibility problems with USB controllers. The project is called HID Remapper, which is short for Human Interface Device Remapper. I discovered this GitHub project when I was reviewing the Taito egret trackball and spinner combo set and encountered button problems. Here it is. Check out the review if you haven't seen it already. The problem with USB controllers is when you press a switch or a button or move the trackball, the USB device generates interrupt codes. So what happens is that some devices generate non-standard codes, and this can be problematic for some software, like for instance MAME in Windows. Well, using the Raspberry Pi Pico based device, we can intercept these codes, change them, and then send them out again to the computer. Onto the project. Okay, now I'm going to show you what the problem is. As you can see, I've got a couple of diagnostic tools up, and the problem is the buttons, when I press them here, not registering at all. But as you can see, the trackball is detected, and so is the dial spinner. It can scroll the menus and things like that. Right, let's see what we can do about this. You're going to need a Raspberry Pi Pico device, which I mentioned earlier. This is quite cheap. If you get it from AliExpress, it shouldn't cost you more than $4. And a USB 2 extension cable, like so, and then you got USB-A on the end. Basically, so what is going to happen is the controller is going to fit into one end here, and the other end is going to plug into, after we snip it off, it's going to plug into this. Oh, and before I forget, some other equipment that can be useful is some wire strippers. These are automatic ones. They're not essential. You could probably do them by hand with a knife or anything like that. And a multimeter. I'm using this simple one here, but it's so useful. It just beeps and everything like that. It's really cheap. Right. First, we're going to have to cut off our extension cable. Make sure you cut it off at this end, not at this end. So I'm going to chop it off using some scissors up here. Now that's chopped off, you're going to need to strip some of the wire back. Just going to get some wire strippers to strip it back. We're going to need to strip a little bit at the end. I've got these to help me. These are not essential, but you can use whatever means you've got. Also, strip away some of these to get at the wire itself. And then we have these exposed. Copper. Should look something like this. And we're ready to solder. Right, I've removed a little bit more of the insulation from the wire and exposed a little bit more. This is how it should look. Okay, now basically the red wire is plus 5 volts, and then you've got the white wire here, that is pin 2, and that is data minus. Then you've got the green one, which is pin 3, and that is data plus. And then you finally got the black wire, which is ground. Yours should match these colors. On the HID Remapper site, his don't match my colors. His was slightly different, but this seems to be the standard color. It's time to solder it up. Before that, let's apply a little bit of flux. Got my flux here. I'm going to flux up to check out what wires we need. GPIO pins 1 and 2, which is these two here. And wires 38 and 40, which is number 40 is here and number 38 is here. So I'm going to apply a little bit to the wires as well. Okay, I've got my soldering going. You've got 300 degrees Celsius here. Right, let's go and solder it to pin 1, which is the green wire to pin 1. So let's pre-tin it first. Okay, I've managed to solder them on. What I would say is make sure you have plenty of insulation removed. Ideally I should have removed up to here, so it'll help you with manoeuvring the wires. Right, I've done a bit of a clean up and now it's just a quick test of continuity. I like using this multimeter because it's quite small and just gets the job done when you're in continuity mode. Okay, checking these two here because they're really close together. As you can see, they're not bridged. Or if you touch them, they are bridged. Okay, now one probe goes in here, and then on the circuit, that one's okay. And they're good. Time to test it out now. Right, here it is, all soldered and finished. As you can see, just the 4 wires needed soldering up. Here's a closer look. Right, the next step is basically plug in a USB-C cable and USB-A goes to your PC, and then hold this button down here, as you can see, and plug it into the PC, and I'll see you on the computer. Right, okay, it's on to the next phase. Now what you want to do is go to this GitHub URL. I'll leave a link in the description below, and what you want to do is find the firmware for the single Pico version, which is this file here, remapper.uf2, and you want to click on that and save it, which I've already done here. There's the file, and we're ready to load up the Pico with the firmware. So let me get that while I plug it in. As you can see, the M drive has appeared, which is that there. So what we're going to do is just copy this file over to it. Now we are done. Right, once the firmware has flashed on it, the Pico, you need to unplug it and then replug it back in to your computer. So I've done that. So now I'm going to plug it back in now. As you can see, it recognized it. Then you want to go to this link here on this website and click open device, and it will appear here, HID Remapper, and then connect to it. As you can see, it's working. Now you can play around with this bit, but I'll give you the configuration for the Taito egret trackball, which I've experimented with, and we'll see how it goes there. Right, I'm going to show you what to do to load the config file up. Once you've opened the device and connected, go to Actions, click on Import. You'll find my HID config, double click it, and there you go. You see all the buttons, how they're mapped. that is the small purple button. It's mapped to number 1. Then you've got the small blue button. Then you've got the small white button. And then you've got the left big pink button, the right pink button. Next, save to device. And that is it. You're all set. One final thing, to configure it for MAME, go to the MAME folder, find this file, mame.ini file, open it in the text editor. Now find this section where it says dial_device, change it to mouse, and where it says trackball_device, change that to mouse as well. I've already done it here, as you can see. They were originally set to keyboard. And then save it, and you're all set for MAME. Now here's the utilities again I brought up onto the PC, and I've plugged in the HID Remapper in, and as you can see the trackball is detected as a mouse, so is the spinner as the cursor moves left and right. Now let's see what happens when I press this button. As you can see, the Z button is pressed on the keyboard, and I've programmed these to generate 1, 2 and 5 for player 1, player 2 and 5 for insert coin, and everything's functioning okay. It was originally left control this, but it was interfering with the KVM switch, so I changed it over. If you want to know what the HID Remapper does, check out the URLs which I'll leave in the description. There's a fairly extensive documentation. He also has a YouTube channel with various things on how to use it and change the inputs and the outputs. It's fairly straightforward. He's got various settings as well, which he basically saved, as you can see here. Our HID Remapper has been paired already. This is not a tutorial on how to use it, it's just how to build it. So check out the website properly. But if you just want the config, I'll leave the config in the description below and you can check it out. Many thanks to Jacek Federins for making this project. It's a great little project. Also a huge thanks to all the 700 plus subscribers who subscribe to the channel. It really helps to motivate me to make more stuff, so big thanks to that. And thanks for watching this video, and I'll see you in the next video. Cheers for now. Here's a few games I tested out. First up is Sega Sonic the Hedgehog, which uses the trackball. Here's another trackball game.
Checkpoint. Ready, go! Steady, you're about to enter the S-curve zone.
Finally, we have Chase HQ, and this used the spinner just like a steering wheel, and it was quite enjoyable to control.
Okay, you're under arrest on suspicion of first-degree murder.